I was busy explaining this here. Uh, when we throw the stone upwards, it will reach a maximum height and then return to where it was thrown. So the velocity of here will be the same velocity of here, but in the opposite direction. If it left at 10 meters per second, then here it will have negative 10 meters per second. So what happens to the speed when it is busy falling down? Of course, it will increase. It will be minus 10, minus 11, minus 12, up to minus that number there that we don't know. That's why here we have this graph here exceeds this here. Because the speed increases. It is busy falling, but in the negative direction. Let's say that you chose downwards as positive. If you choose downwards as positive, of course your speed will be decreasing when it goes up. So it will be like this. Your speed is decreasing, and when it is, this is when it's going up, but when it starts coming down, your speed will start increasing, but in opposite direction, like this here. It depends on your direction of motion. Your direction of motion will like it will affect your how your graph will look like. So a person who drew a graph like this and a person who drew a graph like this, they are all correct. And this time here, T3 tells us when the stone hits the ground and stop. And please do not show this arrow here. This arrow means that it is still moving, whereas in real life it has stopped. So please do not show the arrow. And let's move to the last type of graph. I hope this is clear. We said this is the initial velocity. This is the time it takes to reach its maximum height here. This is the time it takes to return to where it was thrown, which is here. And this is the time of the entire motion, which is here. So it's the time from here to here. So it's the entire time. T3 here is the entire time. So let's move to the last type of graph that we might see is still a velocity time graph. So I will explain why it is a straight line in just a few seconds. And yeah, let's say we are on the same building here, and we throw a ball upwards with a speed of v. This ball here will go up and return to where it was thrown. This is where it reaches maximum height. It will return to where it was thrown here, and then it will go to the ground. What happens when it goes to the ground? Of course, it will bounce and then come to stop. So this is what's happening here. We threw it with an initial velocity, which is here. It reached its maximum height, which is at t1 here. It returns to where it was thrown, which is here, and then it continues moving. It does not stop until it hits the ground at this time here. Sorry if it's not straight. It hits the ground and then it bounces. So what happens when this ball hits the ground? Of course, it will stay on the ground for a few seconds. It will be like this. It will hit the ground, stay for a few seconds, and then bounce back like that. This is what's happening. When it bounces back, it bounces with a certain velocity. And that's why here there is a the time elapse here. So if you want to determine how long the ball was on the ground before it bounced, then you will say t3 minus the time that is here. So we will find how many seconds the ball was on the ground before it bounced. And one question that they might ask you is that how many bounces are represented here? Someone might say there are 2 bounces, which is wrong. There are not 2 bounces here. There's only 1 bounce. Because this here represents from when the ball was thrown up and then it came and hit the ground. So this represents the first bounce, and this can continue on and on and on, and until the ball comes to stop. But here they show only one bounce. And yeah, I think we are done here. Of course, it will bounce with a certain velocity. It will reach a maximum height, which is here. Let me highlight that. This is where it reaches its maximum height here, and this is where it returns to the ground. This time here, it takes this time here to make this ball return to the ground and then stop. And let me show you why this is a straight line. If you remember very well, in my first video of projectile, I introduced some few formulas. Let me look for them. I introduced some few formulas. In that formula, then there is a formula which states that Vf is equals to, let me show you there, it's here. So it's a velocity time graph. We are talking about this here, this formula here. So let's write it in a different way. No, let me write here, because I see I will make a mess there. So it's Vf is equals to Vi plus G changing T. Let me write it in a different way, but I'm not changing anything. It's G changing T plus V initial. So in mathematics, I'm sure you are all familiar with this formula here, which says y is equals to mx plus c. They say that this is the formula for a straight line. And let's relate the two here. So you can see Vf is equals to y, and mx is equals to g changing t, and c is equals to vi. So that's how we have a velocity time graph. It's a straight line like that there. And yeah, this is all I wanted to say about the graphs of motion. It's very easy to analyze them. And yeah, I will see you in the next videos where we will do an activity based on velocity time graph. Until then, I will see you.